Good morning and welcome to this special webinar sponsored by Green Prisons, taking a look at another form of solar than we've discussed before. This one will utilize ultraviolet as opposed to flat panel collection systems, and we've got some experts with us this morning from Solar America Solution. And without too much delay, we're going to go ahead and get started because we've got a lot of information to share with you this afternoon or this morning. But real quickly, I want to introduce you to the primary speaker this morning will be Don Kramer, and Don is the Vice President of Research and Technology for Solar America Solutions. We want to welcome Don to be with us this morning, along with Charlie Slavic and Dave Kramer. So with that, I want to do just as we normally do and get a few of the housekeeping things out of the way, and then we will immediately turn it over to Don for his presentation. We typically will ask you to hold your questions. If you look at the dashboard on your screen, you have a raise your hand icon that lets you know you have a question. We're going to ask you to type that into the question box. You can just click on the little plus sign next to the questions and type your question in. We do that to keep the flow of the presentation moving, and also to try, for the sake of time, to when two or three people might have a similar question, to try and draw them together and consolidate it into one question that I will then present to whoever seems appropriate. If, however, it looks like you've got something that is absolutely burning and is totally unique, then we may go ahead and present that question during the presentation. Also, we're going to ask you at the end of the seminar to complete the evaluation. You'll have the opportunity, you'll get a prompt at the end of the webinar to provide your feedback, and we will we would very much appreciate hearing from you about how you felt the webinar went. We also we anticipate that this will take about 45 or 50 minutes, which will allow about 10 or 15 minutes for questions and anything that you all might want to comment on, particularly as we look at comparing and contrasting these two approaches to technology. At the end of the webinar, before we sign off, we're going to give you some information about the Second National Symposium on Sustainability and how you can meet these fellows in person and also be able to check out the technology not only in an exhibit environment but also live as well. So with that, and no further ado, we're going to move along, and I'm going to introduce you to Don Kramer. And Don, we're going to let you take it away. And I understand you got a little bit of a cold this morning, so if you start to get a little gravelly, we may throw this to one of your partners here. But welcome to Green Prisons and welcome to the webinar.
Hey, thanks a lot, Tommy. I appreciate that. Very much appreciate the opportunity to talk about our technology and what it can do for folks in the prison environment. I wanted to start with this slide because I've been a big fan of Thomas Edison. He's made a lot of things that changed the world and things that were once unheard of and now are used every day by all of us. And one thing that he said back in 1931 that I find very, very attractive is I'd put my money on the sun and solar energy. What a source of power. I hope we don't have to wait until oil and coal run out before we tackle that. So I just wanted to put that quote up there. This was, 80, 90 years ago when a man of vision saw the potential in solar energy and what it can do for us. And I'm happy to tell you that we've now reached a place that we can put his thought into action. So that's all I need to say about this slide, Tommy. So next slide. I just want to explain a little bit about what solar thermal heat actually is. The solar thermal is heat that's generated from the sun, not to be confused with electricity that's created by photovoltaic panels or PV. There's a major difference. We produce BTUs and lots of them. We do not produce electricity. This heat is created from what we all receive every day for free, and that's sunlight. The two different types of solar thermal collectors, one uses infrared heat. Those currently, or for the most part, are known as flat panel or flat plate collectors. And then there's those that use ultraviolet light, which is an evacuated tube collector, which is our type of technology. The beauty of ultraviolet is it penetrates the sun. So there's a major difference. I'm sorry, it penetrates the clouds. So there's a major difference between what the two collectors are able to do in less than perfect weather. Solar thermal heat's produced directly and very efficiently from solar ultraviolet or UV radiation. That's an evacuated tube technology. It is definitely cutting-edge 21st century technology. UV radiation is present before the sun rises and after it sets, which broadens the solar window. Just like you get a sunburn on a cloudy day, UV energy creates a great deal of heat even when the sun's not directly shining on you. In other words, it's behind cloud cover. And you can also get that sunburn on a freezing cold ski slope because UV energy creates a great amount of heat even on the coldest day of the year. So next slide. So how is it captured? How does solar thermal heat work? A flat plate collector makes up to about 80 to 100 degrees Fahrenheit. It's used basically in maybe cleaning where you need some warm water, washing, and preheating then water to be fully heated by a traditional source. Evacuated tube collectors, a traditional evacuated tube collector, it gets up to about 120 degrees. So it's great for domestic hot water, swimming pool, preheating for space heat, some of those things. So it's a little more effective. A traditional evacuated tube collector is a bit more useful than a flat plate collector. Next slide, please. All right, so now we're going to talk about the SunQuest 250, which is the evacuated tube collector that we invented. Is patent pending technology. The first generation was pretty much the same as all the other traditional evacuated tube collectors. Second generation, our first patented model, we were able to get up to 180 degrees. So now we're very, very useful for domestic hot water, space heating applications, industrial process water, and so on. And then we came up with the third generation, which is our latest patent. It's patent pending currently. This third generation collector is unbelievable in its ability to produce heat. We can get up to 350 degrees. And those test results are verified by independent lab tests done at the Midwest Renewable Energy Association test lab in Custer, Wisconsin. So now we're up to domestic hot water, space heating, processed water, chillers, steam turbines, water purification. The list goes on and on and on. We're talking about a tremendous, tremendous amount of heat production. Next slide. So what is the SunQuest 250? It's an evacuated tube solar thermal collector panel. And I would like just to take a second to explain what an evacuated tube is, although we'll cover this a little bit later. But an evacuated tube is actually a glass tube inside of another glass tube, and there's vacuum between them because of the insulation value of vacuum. So when we speak about evacuated tubes, we're speaking of a tube inside of a tube with vacuum between the two. It's the most effective and efficient solar heating product on the market today, and the SunQuest 250 is remarkably more efficient and more effective than anything else out there. The first production models have proved to be 25 to 40% more effective than our closest competitor. Proprietary and U.S. pending improvements have now made it even better. So thanks to this new technology, the SunQuest 250 makes it practical to heat space in residential, commercial, industrial facilities for the first time ever, truly. Next slide, Tommy. So this is a picture of a SunQuest 250. You can see it's markedly different in looks than a flat plate or flat panel collector. You can see through it. So there's obviously some merit there for security purposes. It's not like a big sail, so it doesn't catch wind. So this just gives you an idea of what a panel looks like. Next slide. All right, this was an installation at a 165-bed facility. We're doing about 95% of the hot water needed for that facility, which includes showers and also some kitchenette responsibilities as well. So you can see this is done with 10 panels, and this is what a typical installation would look like. This is the glass tubes actually being installed. Just wanted you to see how easy it is. This is not a tough or difficult installation. It requires a little plumbing skills and then the ability to push a glass bulb up into a header component. So very easily installed. And again, you can see from a security standpoint how open this is. There's no hiding places behind it. Next slide. All right, so how does it work? We're going to get into the nuts and bolts here just a little bit, not going to get too technical. But the UV rays from the sun create friction as they're absorbed by those collector tubes. BTUs, or heat, is the byproduct of expended energy, so we force the UV rays to expend energy as they penetrate that coating on the inner tube. The friction creates heat, and then that heat can be used into water, typically to be used for space heating and domestic hot water. The SunQuest 250 integrates seamlessly, and I mean that very, very much. It is a seamless integration into forced air gas, oil, heat pumps, geothermals, water to water, you just name it. It's very seamless in its integration, so you don't have to tear out everything you've got to put in something new. This is just an additional source that supplies heat to your existing system. And it really is unprecedented heat output. Our nearest competitors produce, according to their rating, they produce about 40,000 BTUs a day. That's a solar day, so 10 daylight hours. Our panel produces 30,000 BTUs an hour, so that's 300,000 BTUs a day. That's 6 times more output. And again, this is not our numbers. These are verified numbers from a couple of different sources. Here you see a graph. This was a side-by-side test done at an independent laboratory, testing our panel versus one of the leading panels that's manufactured in the world. And it becomes very obvious the difference when you look at output temperature, because the higher the temperature, the more BTUs you're creating. Next slide. Again, this is comparing our panel against a 25. Our panel has 25 tubes, and comparing that to a 30-tube collector, again, one of the highest rated in the world. And once again, you can see the difference in the temperature in the tube and the temperature in the header. And the header temperature is the temperature that you're going to bring in. That's the amount of BTUs that you're actually going to collect. And you can see there's a tremendous difference between our collector and one of the highest rated collectors in the world. Next slide, Tommy. I wanted to put a little picture in here just to give you an idea of kind of what a system looks like. And you can look at this and very quickly see, one, it's quite simple. 2, easily integrated. And 3, using this solar tank as a preheat vessel, for your domestic hot water or for the showers and hot water in the facilities. You can see it's very simple, and this solar tank then becomes the primary source of heating that water. So instead of using your boiler to maintain temperature and to keep temperature at whatever your target temperature is in your storage tank, you can see the solar does all the work now, so your boiler doesn't have to run nearly as much. Typically, we're going to cut your boiler usage by 50 to 70%, maybe more than that, depending on your application. So this is just a quick little overview of how the system works, and then you use the excess heat. When you don't need it to heat water, you use the excess heat created to go through a heat exchanger and then blow heated air into the space that the system's in. Next slide, Tommy. Okay, now here's the science behind our collector, the SunQuest 250. You can see in this picture there's a glass tube inside of a glass tube that I spoke about. And then you can see the black coating that's on the inside of the inner glass tube. That's the coating, that sputtered coating that forces the UV rays to expend energy as it penetrates. And in doing so, it creates heat. And that heat then is transferred by what we call a heat pipe. The item in the center, it's a little capillary system. It strictly evaporates and condensates. And in that process, the heat's transferred into a collection fluid that runs through the header itself. So no water runs down inside of this glass pipe. There's no worry about freezing. It's a sealed pipe with a heat transfer that takes place at that bulb at the top. Next slide, Tommy. And by the way, this is not our evacuated tube. This is a competitor's. There's a lot of people would like to have some information on what we've got, so we don't put pictures of it out. But you see a double-walled vacuum insulated tube we've already spoke of. You can see the black absorption layer. You can see heat transfer fins, and then you can see this heat pipe that particular model runs down the center of the pipe. Next slide, Tommy. All right, so let's look at this condenser a little bit. This is the heat pipe that transfers the heat from the glass bulb to the header that we call it, where the fluid transfer, heat transfer fluid is flowing. This condenser bulb is the most important part of that. The more surface area you have, the more heat transfer you get. And again, anytime you see a braze spot, that's a weak point, and you see the weak point on this particular heat pipe. There's two heat points at the area of transfer. So we've done away with that. Ours is made in a different manner, so we don't have those weak spots that can fail, because we want to make a system that's absolutely trouble-free. Next slide, Tommy. Okay, so here's the header that I spoke of. If you see the copper-colored pipe running through that, that's where the transfer fluid runs through. Again, this is not our SunQuest 250. This is a leading competitor. You can see that the heat pipe bulb actually is below and above that copper pipe, so much of the surface area cannot come in contact with the collection fluid running through. That's one thing that we re-engineered. Ours is in complete contact so that we have much more surface area. We can transfer much more thermal energy at a much quicker rate. I'd also like to point out the insulation, and you can actually see the gaps that are in this insulation, the gap at the end. So again, it's a loss of efficiency. You pay to collect BTUs, and then you allow them to escape out into ambient. That's a waste of money. So our insulation is fiberglass and then foam, so we're completely sealed. We have 2 to 3 times more insulation than our closest competitor. So that's just an idea of some of the things that we've done that the other folks haven't done, and that is we want to keep every BTU that we collect. We want to keep it in play instead of losing it out to atmosphere. Next slide, Tommy. This is a heat dissipator. This is a safety feature because we can make so much heat and so many BTUs that sometimes there's certain times in the system where everything is satisfied, you just don't need the heat. So instead of just letting the system set and continue to overheat, there's an automatic valve then that switches. It runs the fluid through this heat dissipator and basically just dissipates the heat back out into the atmosphere so that you don't have any overheating safety issues in your system. Next slide, Tommy. This is basically a pump station and controller. The pump station's job is to circulate the collection fluid, and it also has attached to it then a microprocessor that we call a delta T controller. Basically what it's doing is checking temperature at the header, checking temperature at the storage tank, and whatever else you want it to do. And then it both turns the pump on and off and controls the speed of the pump so that you get maximum amount of collection regardless of what the weather conditions are on the outside. Anytime there's BTUs that are usable and available, this pump station knows it, turns it on, so you get them all. You collect every BTU that you produce. Next slide, Tommy. This is what a typical storage tank looks like. As you can see, it looks remarkably like a hot water heater. It's just much better insulated and doesn't have additional heating elements in it. This is strictly a preheat. This is what you would then use to refill your existing water tank as it empties. Instead of refilling that with 50-degree water from the city or from a well, you would refill with water that's already up to temperature and ready to go. Next slide. This is a remarkable little vessel here. This is called a Solar Phoenix, and the little black box that you see mounted on there is actually a high-efficient 97% boiler that's built right into the storage tank. So typically we use these in processed water where the solar is the primary source and the boiler is the backup source, and the boiler and the storage tank are all in one. Makes for a very tight, easy installation. These work very well for like radiant floor systems and those sorts of things in maintenance rooms and shops and warehousing and those sort of applications where you can use floor heat to cut your heating costs by a tremendous amount. Next slide, Tommy. And this is what one of those installations look like with that tank. This actually is a 12,000 square foot facility located in western Ohio, and that entire building, 12,000 square foot, 18-foot tall ceilings, is heated with radiant floor. And in this particular instance, the solar as primary supplies all of the heat for the building. They don't even have the gas turned on to the boiler. It's there in case they need it, but we're now coming into our third heating season, and they've not used it yet. Next slide. So this just gives you an idea of what an installation actually looks like. We got the solar tank, we got the pump station, and you can see the insulated piping running to and from. In this particular instance, this is not being used for domestic hot water. This is actually being used to heat 3 different zones in a building. So this tank and this solar system is supplying the heat for space heating to a fairly large, I think it's about a 7,500 square foot office building. Next slide. The reason this picture's in here, I wanted you to get an idea of the heat that we can create. This is the controller for the radiant floor system that we just spoke of a couple of slides ago. Actually, it should say 10 collector panels. It says 2. I'm sorry, it should say 6 collector panels, and it says 2. But you can see this is on a cloudy winter day in mid-January. We were out there with a training class, and the collector was making 162.5 degrees. So again, it just speaks to the efficiency of the SunQuest 250 and what you're able to do with that. So we're very proud of this picture because it's a real-life window into what this system can do. Next slide, Tommy. In case any of you have never seen a radiant floor prior to the concrete being poured on it, that's what this picture is here. You can see it goes under the rebar with insulation underneath of it, and that's what keeps the radiant coming up. That's how it radiates up into the building. There's insulation underneath PEX. The PEX is very straight when it's laid out like this, and you get perfect heat distribution across the entire floor. Next slide, please. Great return on investment. That's something all of us are looking for. And this is a typical installation, and it's a very, very typical cumulative cash flow. You can see that it pays for itself, which is the red portion. It pays for itself just under 5 years, this particular installation. And then over the course of the next 20 years, this customer was able to save about $180,000, which is a huge amount of money that you get return on what was about a $35,000 investment. So these are not expensive systems. They're very, very easily installed. They're very, very simple. They don't add maintenance costs, and the return on the investment is absolutely wonderful. Next slide. Charlie, I'm going to ask you if you would jump in here. I apologize with my throat. I'm having a little throat issue today, and I'm just about to lose my voice. So if I could get Charlie to jump in and kind of take this for me, I would definitely appreciate that.
All right. Can you guys hear me?
Right. Go right ahead. Yeah. Go right ahead, Charlie.
Okay. As we move along here, in focusing and looking at more of what we can do, because we do bring more to the table than just the heat and the BTUs. You know, how does this work for prisons? One of the major areas we're finding is that we're able to put together programs, as we are with the folks in Indiana, for inmate training opportunities. This is really a burgeoning industry with a tremendous amount of upside, and gives inmates and offenders a chance to get some real world practical experience in again an exploding market. Give them a little bit better chance on the outside, and maybe reduce the recidivism by making sure they've got some skills to go out and get a job. The system components, some of the components are actually manufactured by prison industries. Here in Indiana, Penn Products makes all of our frames for these prison jobs. So you know, we've got it's a good situation for offenders as well, because you know, you might have a guy that's I think, as Tommy brought up once, that you know, maybe he's doing 15 to 25 for armed robbery, and you wouldn't necessarily want him on the outside installing frames and collectors, but having them working inside, making the frames, is a good idea, and it's a good thing for everybody concerned. We talked about energy savings with fast return on investment, obviously a hedge against rising oil and gas prices, and an opportunity to go green. There is another thing involved here too that we don't have on this slide, and that is that we have leasing available, and which turns out to be a very, very good thing to create a budget-neutral situation for departments of correction. In other words, the savings on fuel usually more than covers the cost of a monthly lease. So it works out as kind of a win-win for everyone. We go to the next slide, Tommy. Okay, this is at the Wabash Correctional Facility. These panels are up there currently. We'll be on a building right next door. And this is kind of what they look like. These are flat panels up there right now. But as you can see, they don't take a whole bunch of space, but they do produce, we will produce a tremendous amount of energy to offset costs for Wabash Valley. Next slide, Tommy. Okay, the training opportunity that I mentioned. We can train inmates to install the system. We actually had a meeting at Wabash Valley about a week or so ago. Don and I were down there working with the staff to set up. They have their folks already picked out and so forth, ready to go. The crews to install this system. And again, renewable energy, rapidly growing field, really a good opportunity for inmates to have to gain experience, valuable experience in an area that's going to grow over the course of the next many years. There are few trained technicians in this field. We work with, as Don alluded to, the MREA, the Midwest Renewable Energy Association up in Wisconsin. They train installers, and there are a couple of other places around the country that do. But it's rare to have an opportunity to get installation training in this area. Huge demand, and it's growing as energy prices continue to creep up. The components manufactured by Prison Industries, we are absolutely dedicated to be made in the USA, and we can say that. We have some components that are manufactured offshore. They have to be because the EPA says that some of the materials are dangerous in their raw form and so on and so forth. So we have to have that handled. But the dimensional aluminum fabrication for our framework and some of the plastic components, and will be manufactured here and by our partners at Penn Products. And assembly of these products is actually done mostly on site. We assemble, when we get there, we ship it on site, assemble there. Next slide, Tommy. We spoke about fast ROI. Again, we find that in most of the instances that we're talking to prisons with fuel budgets of $1 million plus per year. We like to be conservative. We project fuel savings somewhere around 40%. We generally do much better than that, but we want to be conservative in our projections. And of course, it is more the farther north that you go. Typical ROI is less than 5 years, and again, the lease plan with no down payment and flat budget numbers means that we can create a budget-neutral situation for departments of correction. Well, the opportunity to go green. Of course, green initiatives are going on in many states and many industries, but our application, the expected life of this system, we don't really even know. Our manufacturers, the component guys, tell us that it's about, that they can tell us 25 years. Truth is, we don't really know. There's really no moving parts other than a small circulation pump that can plug in and out. This is really the only application that pays for itself before it wears out. When you have PV installations, the photovoltaic cells have a tendency to degrade over time, and not that much time. You start having to replace those cells and those panels after 3, 4, 5, 6 years. So it's clean and quiet. Again, no moving parts, and it's a responsible thing to do. It's a good solid citizen thing to do. Okay, kind of to recap what we have going on and what we've learned. Inmate training opportunities, which become more and more important as prison overcrowding becomes a problem and recidivism is a problem. System components are manufactured by Prison Industries. It's really a good thing. It truly is a partnership. They become our customers and we become theirs. Energy savings, fast ROI, the opportunity to go green and to do it all and create it all in a budget-neutral way. Okay, do we have any questions?
Yeah, let's give you all a moment to formulate any questions. If you want to, just click the hand-raised icon on your dashboard. And while we're waiting for some of those that may come from the field, and I will throw this out to all three of you gentlemen so you can unmute your microphones. as you respond. But if we could revisit the project that you have at Wabash for a moment, and just sort of maybe give a little more detail on how long the installation process takes from start to finish, and exactly what the application will be for this technology at Wabash. What in fact are you supplying hot water to? Are you supplying any heat, etc.? And I don't know,
Okay.
Charlie, you want to take that?
Yeah, I'll take that. The application at Wabash Valley is primarily hot water for inmate showers, but we're going to produce excess heat. So we'll be putting a coil, sticking a coil in the furnace, which there are, I believe, at each cell block 7 furnaces, and our system happens to be, we'll be sitting right next to one of those. So we'll be able to put a coil in the furnace to help augment, space heat as well. This application, in this particular installation, though, is dedicated strictly to hot water. What we'll do is put a tank, one of the tanks that Don was talking about, and you've seen the picture of. We'll install that next to the existing boiler and heat water to, I'm not sure what the target temperature is, but likely somewhere in the 180-degree range. Dump it into the existing tank to mix with ambient water, bring it down to likely somewhere around 120 degrees or so. The installation itself, I don't know how long it's going to take with the plumbing on site. They've got to run some pipe and so on and so forth. But again, these are all plumbing issues, things that the guys on staff can do. The actual installation of panels should take, to put them together and get them up on the roof and so forth, likely 7 to 10 days.
Okay, so following up on that just a little bit, you are in the process of that project now, and as I understand it, you anticipate having that project up and running hopefully by the end of this month when the symposium is held in Plainfield, Indiana. Is that correct?
That would be correct, yes. Mm-hmm.
And either at that facility, or I know you have another installation elsewhere in the Indianapolis area, there'll be some opportunity to physically look at these installations, and for folks like me who tend to need a hands-on and be able to touch it and feel it kind of thing, there'll be an opportunity to do that after the symposium on Friday.
That would be correct, yes. And of course, we'll have our booth set up at your symposium and materials for folks, and be available to answer any questions they might have.
Okay. Let's see. It looks like we have a question from Al Hare out of North Carolina. Al, if you want to, your question is, how can the system be expected to last in areas prone to high winds or areas of large snowfalls? An excellent question. So how does the ambient weather affect these systems? And as I once asked you, what keeps those little glass tubes from breaking?
Well, our panels, they're unlike a flat panel, which sometimes can be like a big sail up there in the wind. Our panels are a series of 25 tubes, so wind passes, right through them. They're built to withstand 150 mile an hour, wind load. So which generally isn't, if you got 150 mile an hour wind load, you're going to have more to worry about than a solar panel, for sure. Also, they are warranted for 1.5 inch hail, and the circular nature of the tubes, it really has to be an incredible direct hit to be able to break one of these things. They're very, very tough. They're made out of borosilicate, which was the stuff that Pyrex used to be made out of, and it's a very, very tough glass. If one does break, replacement tubes, glass tubes, are like $25 or something of that nature, and they're not wired. It's not set up like those old Christmas tree lights where if one goes out, the rest of them don't work. If you break a tube or two, or depending on how the weather or whatever factors, the rest of the tubes keep producing heat, as long as while you repair it, while you put another tube in. As far as snow is concerned, you know, we have a picture that of one of the collectors with snow about a third of the way up that's still producing about 150, 160 degrees. UV rays penetrate snow to a great degree. Now, if you get 6, 8, 10 inches of snow on top of the thing, again, you're going to have a little more to worry about than solar heat. But it gets a little dicey there. It really won't do any good there. But cloudy weather, snow, rain, UV rays penetrate it all. And, you know, some days are better than others, but we're still producing heat.
All right, we have a question from Art Krebs. He wants to know how large is the installation that will take you 7 days or so to put up. So that's the Wabash. Once you get started on that, how long do you anticipate that'll take to set up?
Well, it's a little bit different in as much as we'll be training people. So, you know, that's going to take a little bit more time to put together. We have a couple of installations on the table now. That one is 175 panels. The other one that we don't have any word back on yet is 120 panels. That's going to take somewhere in the neighborhood of 3 weeks or so. But again, we'll have contractors that we recommend, that we've trained and so forth, that'll be traveling and or you know, actually doing the installation and overseeing it. But when you're training people, it takes a little bit longer.
Okay. But rough, and again, every site is going to have its own specific requirements depending on the age of the building, how much pre-plumbing work and stuff you have to do. But in general, 30 days plus or minus is a reasonable expectation to get these things up. And yeah.
Yeah. What the actual installation at Wabash, we figure about 10 working days.
Okay. All righty.
Okay.
And we have a question from Andrew Newman, and he wants to know another excellent question. What's the ratio of energy you have to put into the system to get the energy out? In other words, how much does it cost to run the pumps, et cetera, and where does that energy come from?
Oh, gee, what is the horsepower?
Let me take that one, Charlie.
Yeah, go.
Mm-hmm. Yeah, this is Don. The only energy that's expended in this system is from a small, typically Grundfos circulating pump. It's 1/25 horse, pulls about 3 amps. So the input is minimal compared to the huge output that you get. So you have very little input cost or energy expended to gather this energy back into your system where it's used.
Okay. Is there? I'm gonna show my ignorance here, but is there a certain amount of can you quantify that at all, Don, in terms of X number of kilowatts or whatever?
Yeah, it's like I said, the pump pulls 3 to 4 watts.
Okay.
So a kilowatt's 1,000 watts. So you can do the math. Typically, I think a kilowatt somewhere around 12 cents from the electric company, 12, 15 cents, depending on where you're at. A little more than that on the east-west coast. A little less in the Midwest that's currently coal-fired electrical generation. So there's very, very, very little. I mean, a minimal amount of energy expended to gather this energy back in from the solar system.
This is Dave. If I can just add a comment to that for Mr. Newman. As Don's pointing out, monthly your energy expense for running this little pump would be calculated in cents. You know, maybe 25 cents or something. It's very, very minimal. The output we're showing in terms of BTUs, and Don can give you the calculation for BTUs converted to kilowatt hours, and you can from that derive a little bit of information about the efficiency. The whole point of this system is that you're basically getting pretty much free energy from the sun that's going to be replacing 40 to 70% of the energy, the fuel that you need to run your heating system. And Don, do you have that calculation?
Yeah. 1 kilowatt hour is 3,420 roughly BTUs. So you can see by the earlier slides that our panels will produce up to 300,000 BTUs per day per panel. So the return on 1 kilowatt hour of energy is tremendous. Would be hundreds of kilowatt hours in return.
We have another question from Randy Canterbury in Ohio with the Ohio Department of Rehabilitation and Correction. He wants to know, do you have a smaller scale system that could be implemented as some sort of test program, maybe something less than $5,000?
Well, what we have is silence on the other end of the phone here. Already the systems that we sized are all dependent on what kind of output that you need for the use that you're going to, whatever you're going to be using it for. If you're, classic example, if you have a small office building, it's going to be providing, hot water for hand washing and just a little bit of kitchenette work. You don't need that many panels. It just depends on the size. But I'll tell you, if we can get Tommy, we'll have Randy's contact information out of this. So why don't we contact you? I'll tell you what, I will contact you, Randy, and we can talk down through that. I think the short answer probably is going to be yes, but we'll need to talk down through it and see what it is that you want to do with it.
Okay.
And this is Dave again. Yeah. If I can point out something, Tommy, also, we talked about this installation at Wabash Valley. One of the nice things about the installation is that the Indiana Department of Corrections is interested in seeing the comparison between the system that we're putting on the roof of one of those buildings, which is immediately adjacent to the building that already has a flat panel system on it. And then the third building on the other side of the one that we're putting our system on will have no solar assist whatsoever. And they're going to be keeping accurate records of how much fuel is used in the building with no solar assist, the one that has a flat panel assist, and the one that has our system on it. So that's going to be kind of an open kimono opportunity to see how efficient the system is without other facilities having to expend any money whatsoever. And the other point that I wanted to make, and we will make that information available on our website, by the way, and the other point that I wanted to make is that a lot of the expense of the system is in the components that you pretty much have to have, whether you have one collector or multiple collectors. So trying to get a system installed just for test purposes, the panels themselves are not terribly expensive. They're a couple $1,000s a piece. But by the time you get all of the other components in place, whether you're running one collector or multiple collectors, you've had to put money into pretty much the same system that you would have to have if you had one collector or 10 collectors.
Let me move real quickly. We have another question. We're getting a little short on time here, but we've got 2 or 3 others that we want to try and get to. We have a question regarding access to the slides and to this webinar, and I'll take that one real quick. We archive all of our webinars presented by Green Prisons, and as we will this one, it will be available on our website as well as the Solar America website probably by this weekend. Typically it takes us a couple of days to get the files from the provider and get them up on the website. But you will be able to access the slides and all the narrative and all these questions and the responses to folks from both those websites certainly by the 1st of next week. Let me see. We had a question from, if I can find it real quick, George Berghorn. Yeah, there we go. George had a question whether efficiency curves are available. George is the chair of the department at Community College in Michigan. He wants to know if efficiency curves are available, one for solar energy conversion efficiency under the various end uses at various ambient temperatures, and two for efficiencies under varying values for the temperature difference between inlet water and ambient environment. Somebody want to take that in 25 words or less?
The short answer to that is because the third generation, the SunQuest 250, is absolutely new to the market, just into manufacturing in a very short time. We haven't been able to put those charts together yet, so the short answer is no, but that will be coming once data becomes, more data is collected, and we can do that.
The other thing I would point out that in addition to you all, George will be presenting at the symposium as well at the end of the month, and I can envision a very thoughtful and spirited discussion between you all at the symposium, perhaps over some milk and cookies. So we encourage you to consider that. Let me see who else I had a question from real quickly. Let me see, did I get?
Tommy, while you're looking at that,
Sure.
Can you go to the next? Can you go to the next slide so that folks like George or anyone who has questions can have the contact information for Don and Charlie? Oh, sorry, I didn't know I was going that far into your presentation.
Yeah, that's fine. We can back up. Oh, let me back up from there. Yeah, we can back up and do that.
That's the contact information. George's question was pretty complex. I guess that's because it's coming from a university setting. But I think that there's some of those elements that Don can talk through on a one-on-one, George, and then like Tommy said, we would love for you to come by and talk to us at our booth in Plainfield.
Okay, I'm not seeing any other questions out there at this point, and we're running real close on time. Do you guys have anything in summary that you wanted to make sure that gets reemphasized before we wind this thing up for today?
If I can
just
say,
like
one,
to say
thing,
one thing.
Oh, go ahead.
There is a triple bottom line here in this system, and that is we save you money, we train inmates, and we are willing to partner with your prison industries. If that works for you, we are well willing to work with the Department of Corrections in all the states. However best works for you certainly would work for us.
Having had the opportunity to talk to several commissioners and directors about this, the whole sustainable technology and that approach to prison management, I know that that everybody's kind of got their eye on what we can do to keep inmates busy, to keep them occupied, and ideally to do it in a way that provides meaningful work and training experience. And so it's important, I believe, that when you're talking to vendors, and certainly there are many of them out there that are willing to do this, but a lot of them won't think to do it if you don't ask. So it's important to talk to a vendor about, hey, are you willing to help us develop a way to, if we take on your new technology, to train our inmates and put them to work. And the short answer to that is that certainly Solar America is willing to do that, and I think that makes them unique in what they're doing. And of course, it would seem while I'm talking and pushing buttons here, I've managed to get us lost here. But in any event, we do want to thank Don and Charlie and Dave for joining us today and sharing what is, I think, a really interesting new technology. We want to thank, we had over 60 people registered for today's presentation, and if you had any problems with the connection or something happened and maybe you thought a colleague was going to be online with you today and they couldn't join you at the last minute, the opportunity to see the entire and hear the entire webinar is going to be available, like I said, by Monday. We encourage you to do that. If you would like to if you have an idea for a webinar, if there's something that you would like to see us address in this fashion, our webinars are always free to practitioners. And send us, you can send it to me, Tommy at greenprisons.org. Send us an email and say, hey, I'd like to hear more about whatever. Or if you have a product or service that you'd like to make sure that the correctional world is aware of, an opportunity like this is certainly available to you as well. I want to thank all three of these guys for providing us with some really good information today, and the opportunity to hear about this new technology and what's going on in their project with Indiana. I want to encourage all of you to to join us at this symposium in Plainfield, which is right outside of Indianapolis, in 3 weeks. We have a really great lineup of presenters and speakers. You can check out the agenda for that conference at greenprisons.org. Just click on the link for the symposium, and you can look at not only the agenda, but who the exhibitors are going to be, and take a look at the schedule. And finally, as a result of your participation today, we want to encourage you to network back with folks and tune in for additional webinars in the upcoming months. We won't have another one here in October, but we had one at the end of September that we did jointly with the Environmental Protection Association, with the EPA folks, taking a look at their energy management portfolio as it's piloted in the Ohio Department of Rehabilitation and Correction. That webinar will be up shortly too. So we encourage you to check out those or any of the other previous webinars that you might have missed. Again, want to thank our guest presenters today for joining us, and from all of you in the field. We appreciate that as well, and hope you'll tune back in with us next time. Watch your email. If you're not subscribed to the newsletter, do that, and you'll be notified when we do have another webinar schedule. So with that, we look forward to talking to you again in November. Thanks so much, and have a good afternoon, and be safe.